Hello and welcome to lecture series on 8051 microcontroller. In the last lecture on interrupt, uh, the lecture basically ended abruptly. I'm sorry for that. Um let's start with the TCON register to understand how interrupt uh, uh, can uh, be acknowledged in 8051 microcontroller. So TCON register is an SFR, and we were talking that the last 4 bits of TCON register are basically used for the interrupt operation. So IE and IT. So 1 and 1 and 0 and 0. 1 basically stand for INT1 and 0 stand for INT0. That means the two external hardware interrupts. So IE1 and IT1 basically related to the external hardware interrupt INT1, while these two related to INT0. So let's focus on INT1. So whenever there is an interrupt at uh, the pin location P3.3, which is basically the INT1 interrupt pin. So this IE1 is set. Okay, IE1 is set, and when the service routine has been executed and RETI instruction has been executed, then the hardware automatically resets this IE1 pin. I hope this is clear. IT1 basically refers to that we want the interrupt to be level triggered or edge triggered. By level triggering, we mean that when the INT1 pin is receiving a low signal for at least some machine cycles, uh, actually it should be uh, for at least the time ISR execution has started. Otherwise, uh, interrupt will not be acknowledged. Okay, so the other way is when there is a transition from high to low at INT1 pin, then also interrupt occurs. So if we are making IT1 bit equal to 0, then that would mean that we are basically configuring it for the low level trigger interrupt. While if we are setting it, then that would mean when there is a transition from high to low at that particular pin, then interrupt will occur. Okay, so let's move. There is another register called IE register. This is also an SFR, and let's discuss this. So EA is basically enable the interrupts. So if we want any interrupt to be acknowledged by the 8051 microcontroller, this EA pin needs to be set. It needs to be set. Okay, so if this is not equal to 1, then none of the interrupt will be acknowledged. So please ensure that in the program EA is set to 1 so that the interrupts are acknowledged. Okay, these two pins are basically, this is not related, this is for these two are basically for future use. Now these 5 pins, ES is for serial port interrupt, ET1 is for timer 1 interrupt, EX1 is external interrupt INT1, ET0 is timer 0 interrupt, EX0 is the external interrupt 0. So these needs to be set to 1 for these interrupts if they are to be acknowledged by 8051. So any one of them is 0, that particular interrupt will not be acknowledged. Okay, And this diagram basically explains how interrupt work in 8051. So EA, as I told you, if this is 0, then no interrupt will be acknowledged. Okay, so this needs to be 1. While EX0, EX1, ET0, ET1, and ES, they are part of the IE register. And I told you that these we have to put them equal to 1 if we want the interrupt because of these timers or external interrupts. Okay, so these three are the internal interrupts: timer 0, timer 1, and the serial interrupt. While INT0 and INT1 are the external interrupts. So you could see here IE0 and IE1. So if IE0 is 1, then only the external interrupt INT0 is acknowledged. Otherwise, it won't be acknowledged. Similarly, if IE1 is 1, then only INT1 will be acknowledged. But the programmer need not worry about setting these bits. Sorry, they are set automatically by the hardware when there is an interrupt. Okay, then IT0 and IT1. So it basically decides if it is 0, then that would mean there is a level triggering, and if it is set to 1, then that would mean a transition from high to low will result in an interrupt. So similar is the case for INT1. So this diagram basically sums up the working of various registers for carrying out interrupt operation in 8051. Then IP register. So I told you in the previous lecture that the interrupts of 8051 has got some priority. Okay, and that priority can be changed with the help of this IP register. So just see here, this is a register. PT2 is not for our purpose because it is used for 8052 microcontroller, while rest of them for serial port, for timer 1, external interrupt 1, and timer 0 and external interrupt 0. If they are set to 1, so they makes that particular interrupt to be of highest priority. We will try to understand it with the help of some examples. Okay, so I am taking one problem. So the first one is program the IP register, the register which we discussed just now, this register, IP register. So program the IP register to assign the highest priority to INT1. Then discuss what happens if INT0, INT1, and TF0 are activated at the same time. Okay, so we have this IP register. So and we know that the INT1 pin bit, INT1 bit, INT1 means the external interrupt 1. So external interrupt 1 is this bit. So second bit. So if this needs to be set to third bit. So this needs to be set to 1, which we have done it here. Okay, so this number needs to be put into the IP register so that the timer, the INT1 register gets the highest priority. So this B basically signifies that this number is in binary and not in hex. So after this will be the interrupt priority. So INT1 will get the highest priority, while INT0 and TF0 will come after that. So why INT0 and TF0 are in this order? So I told you that by default the interrupts have got a priority. INT0 has got the highest priority, while timer 0 is in the next level, then the interrupt INT1, the external interrupt, then timer 1 interrupt, then the serial port has got the lowest priority. So if we are making int1 to be the highest priority, then this will come above int0. Okay, then int0, and then tf0 comes next. So that is why you could see here that int is at the highest, int1 is the highest, then int0, and then the tf0. Okay, let's take another problem. So the IP register is set by the instruction move IP comma hash this value. This is in binary. Discuss the sequence in which the interrupts are. Okay, so if this value is moved to IP and this is our IP, so basically we're making the third and fourth bit equal to 1. So third and fourth. So external interrupt 1 and timer 1, we are giving the same priority to them. So if we are giving the same priority to them, then what will happen? Then by default, int1 has got more priority over tf1. Okay, the timer interrupt. Okay, so that will remain. That priority will remain, because since we are giving both of them as one value, so the table, just see the table here. So int1 and the timer 1. int1 comes before timer 1. This has got higher priority than timer 1. So again, these two will have the same sequence here, but these two will move above int0 and timer 0. Okay, because they have been given more priority. So that is why they are lying here, while int0, then tf0, and these are the serial code interrupts. So I hope you understood how priority works in 8051 and how IP could be programmed to change this priority of the various interrupts of 8051. We will try to use them in our future lectures when we'll discuss some programs based on interrupts, and we will look how this priority can be changed and how interrupt basically work in a program. So thank you for watching.